Yay! Hello, lovely humans. I'm so happy to be back. I took a much needed break during the month of December. I hope it was as relaxing and enjoyable for you as it was for me. It's winter here for me, and so I had a lot of fun, snowy outdoor adventures. Yay! All right, but let's get into it. Math and making. Yes! We're going to talk about precision. Wait, don't turn it off. It'll be entertaining, I promise. Yeah, okay. And also, precision matters. Why, do you say? Let's have story time to talk about precision. Okay, so I was talking about 3D printing with one of my super cool friends. I got lots of those. Woo! And I was talking about the difference between a cheaper printer that I got for free when I won a contest, which is super rad. It was the kind of kick that I needed to get into 3D printing. I've seen a lot of people, I have a lot of friends that do it, but I never really wanted to dabble in it myself because I was like, I don't really know what I would use it for. So I got this printer and I was like, okay, now that I have it, I should use it. And so I actually got really into printing stuff for wearables and being able to replace parts and things like that. Super fun. But I hit a wall. I would try to print something and the detail just wouldn't be there, or the printer head would get messed up and it would just totally destroy the print. So eventually I was like, okay, I can't deal with this anymore. I want to print this face mask. I'm really into this thing. And so I went and I bought a much more expensive printer. If you take apart a printer, you're probably going to find a lot of the same types of parts, if not the exact same parts. We're talking the same types of motors, the same types of controllers, like the brain of the machine, and the same types of structural elements that hold the printer together. So why is a cheaper printer less accurate than a more expensive printer? Well, hey, we kind of just put our finger on it. It's all about precision. The more expensive printer is more accurate because the designer, the engineer, have put a lot of time and effort and energy and expertise into making sure that the printer and its components are precise. And that requires a lot of work. So let's look at what precision actually means. So precision is really how accurate we are with a given measurement, and we want to be transparent about what we know and what we don't know. If you're like me and you build lots of dirty prototypes with cardboard and hot glue, you probably are just using this, a handy dandy ruler. Yeah, we're going to use metric because it's easier. It makes more sense. So let's use this piece of chalk, for example. I measure the piece of chalk by lining it up on the far left line and seeing which line it overlaps with on on the right side. So this to me looks like 3 centimeters. Let's call it, no, it's like 3.1 centimeters. So that would be 31 millimeters. Wow, okay. So chalk, I was gonna CH for chalk. Okay, so 31 millimeters. But my tool for measuring has a limitation, and that limitation is based on the tick marks or the lines on the ruler. For example, if it was 31 millimeters or 30 millimeters or even 32 millimeters, it's really hard for my eye to see because there are only single millimeter lines. In other, like for example, so if the chalk is kind of here, I don't really know whether if this is 30 and this is 31 and this is 32. Do I call that 31 millimeters or 32 millimeters? I don't really know. I don't know how much of an overlap it is between 31 and 32. So this is where uncertainties come in. Put down a ruler. And so the general rule of thumb for uncertainties is that you add, I'm going to lose any of the space over here, is that you add 1/2 of the unit of measurement. It's kind of a confusing way to phrase it. Oops, no, not 0.5. It's not 0.5, it's 0.5 millimeters. So because our ruler has tick marks every millimeter, the uncertainty is halfway in between those, because our chalk could, be anywhere in between here, and it's difficult for our eyes to see that. Okay, so if I want to be more accurate, what do? Ooh, whoops, upside down. Da-da-da, calipers. These are digital calipers, so a little bit easier to use. So you take these, and this is really hard for me to do upside down, backwards. Camera view. Okay, and you place, there's a few different ways to use these, but I'll just show you how to use the common one. So you place this in between the teeth or the tongues, and then the readout, 32.77 millimeters. Oh, look at that. Okay. Oh wait, I need my chalk back. So ruler and calipers. Oh, I lost my eye. Oh no. Okay, CH equals 32.77 millimeters. And the manufacturer of the calipers actually tells us the accuracy or the precision of this measuring tool. And it is a whopping 0.01 millimeters, 1/100th of a millimeter. I definitely cannot see that with my eyeball. So, hey, that's actually pretty cool. I was within the measurement with my uncertainty. Yay! And this is why uncertainties are really helpful, because I'm being transparent about, okay, this is what I measured, but it's only this accurate. It's only 0.5 millimeter accurate. And this measurement is much, much more accurate. It's an order of magnitude, or it's at least 10 times more accurate, because my uncertainty has decreased to 1/100th of a millimeter. Super cool. Okay, so this is really important when we're building tools like 3D printers or robots or things like that, because we have lots of parts that need to fit together. And so we need to take uncertainties, we need to know what the uncertainties are of all of our measurements. I will also say too that uncertainties combine. So the more parts we have, the more uncertainties we need to combine and add together. So if you are sending parts for someone else to make, you want to be very clear what your uncertainties are, or what the uncertainty is that you want from that person who's making it, whether it's a machinist or a CNC shop or what have you. And typically, the more accurate you need that part to be, the more precise you need your part measurement to be, the more expensive it's going to be, because accuracy is difficult. I can get a ruler for a couple of bucks, but calipers are much pricier because it's difficult to be accurate. And that's okay, as long as we know why and when we need to be accurate. So if you are, making parts for other people to make, you are probably going to want to do computer-aided design, which will help you be way more accurate in your measurements, so that when you send that part off to somebody, it is what you wanted. Okay, I'm not going to get into how uncertainties combine, because it really depends on the situation, but if you're curious, let me know and we can cover that too. Cool. All right, I'm going to leave it there for now. Yay, precision, and yay for making things. I hope that this was helpful. Please let me know if you have any questions or other topics for math and making you'd like me to cover. Yay! See you soon, friends. Bye!